All right. So in 62 in the chapter review, we have this cone, and it's filled with water, or at least partially filled with water. It says water drains from a conical tank shown in the figure at 5 cubic feet per minute. So step one was write down what we know and what we're looking for. Well, we know that dV dt is equal to, and the water is draining at 5 cubic feet per minute. All right? It asks, first question, what is the relationship between the variables r and h?
H over I equals 10 over 4.
H over r. H is to r as 10 is to 4. Okay, and this is really important. These are variable. As height changes, radius changes. Okay, it is variable. Leave them as variable. Sometimes we end up plugging in a particular height or a particular radius late, or too early. Remember, don't plug and chug until after the derision step. Okay. Or we could also call this. Also could be said to be
10r equals 4h.
4h is equal to 10r, or r is equal to 4 over 10h, or 2/5 h. All right?
And then how fast is the water?
How fast is the water dropping when the height is 6 feet? How fast is the water dropping when height is 6? That's our question. Which means that although our initial equation has both r's and h's in it, we don't want any r's in there anymore, because our question is dealing with just h's. If we only had a way to get rid of that r in that equation,
I already did that.
and that is 1/3 pi, and every place we see an r, we replace it with what r is equal to. And now, and don't forget, this is all r, and it's all being squared. So 1/3 pi, we got like 4/25 h cubed. I'm going to clean that one more time. 4 over 75 pi h cubed. Because now I'm ready for the derive and then the plug and chug step.
Why did you plug in R before you tried?
Yeah, isn't that plugging and chugging before deriving?
That's called substituting.
Okay.
Wow.
Oh,
Because r is varying,
Okay.
and we want to make sure that r is allowed to vary before we do our plugging in any values. If we start plugging in what the value of r is, that makes it seem like r is being static. It's not changing. So let's hurry up and do the derivation step. 4 over 75 times pi times 3h squared dh dt. And I wrote improperly v prime here. What I meant to write was dv dt. Okay? Plug and chug. 25. 4/25 pi h is 6 squared dh dt, or -5 is equal to 36 times 4. 6 times 4 is 144 pi over 25, and that's dh dt, and then -5 multiplied by 25 over 144 pi. is dH dt.
Isn't it asking how far it's dropping so the negative goes away?
Negative 0.166 feet per minute is dH dt, and you're absolutely right. And the question is, at what rate is the level dropping? So we present an answer of 0.166 feet per minute. It's dropping, so it is already negative. It's embedded in the language. All right. See you in 100 minutes.